At least we still have some people believing in color, in color for plastic. So thanks for staying for that session. Rowan was making a great job this morning to introduce BASF. By chance, I didn't have the same slides, Rowan. So basically, we are okay. Out of the 115,000 people that you mentioned, we in Colors and Effects, we are a separated subsidiary of BASF, 100% owned. And we represent 2,500 people out of the 115,000, just to give you an idea. And we exclusively focus on colors and effects for industries we serve, which are plastics, automotive coatings, decorative coatings, cosmetics industries, printing industries, etc., etc. Okay. Yeah, so maybe first, before starting, thanks a lot for the association, for inviting BASF Colors and Effects, and myself. I'm very happy to be here. I hope I will make a good job. I hope you will enjoy that talk. It's about colors, and colors usually, imagine the world without any color in the carpets, any color on the seat you're sitting on would be a little bit boring. So we believe that whatever happens with plastics and recycling, there will be still colors on the world. Let me try to move that. Yes, so the presentation. I'm going to be within two specific parts in the presentation. The first part will be to review the trends and drivers which are affecting the plastics market, of course, but really looking at the coloration of plastics point of view. Okay, so we had great presentation this morning about trends in automotive, trends, in bioplastics, but here we are going to look at it from the color point of view. Yeah. And then I will continue by providing you with some practical examples we have been facing as a company and trying to address cases, either challenges or opportunities for our customers and with the value chain. And I will briefly conclude. Yeah, I think when we talk about trends, we usually start with megatrends. That's typically the way at least big companies do and organisms. So megatrends, I think we heard already about those this morning. That's for the next decades. And usually out of those trends, then you can translate those into specific sustainability needs for the market, for the industries. I'm not going to go too much in details here, but those trends can be clustered into specific needs. The pointer is there? Yeah, that's the pointer. Renewable resources, resource efficiency, health and safety, etc., etc. And that's the way BASF as a group is managing the sustainable steering of its portfolio. Now, once we have defined the needs of the market, these have to be translated into requirements. And usually the requirements are set by authorities, regulation bodies. You heard about US FDA, you heard about European Commission, we hear about the GB in China. But we have also industry associations, ETAD for pigments and colorants. We have plastics converters in Europe, we have master batch industry, and those people are trying to cope with the trends and to see as an industry how they can basically address those. Things which are becoming more important are the certification bodies. What are the systems where people act along a certain value chain? For instance, here we can mention Ecotex for fibers. You can have the building initiatives or cradle to cradle, which is going across specific industries. And last but not least, the brand owners, which are the people serving consumers. Those people have a high brand value in the market. And they also here are very active in preserving their brand, preserving also the safety of the consumers. And those people usually, they tend to specify their own requirements and also try to design their products by avoiding the presence of some chemicals in their products. So you see that us in colors, we are very much upstream. So basically all these requirements coming from automotive, packaging, cosmetics industries are coming back to us through the value chain and through the master batches, which are our customers. And you see that there is a wide bunch of requirements coming back from all these organizations and bodies. Now, once you have basically said, I want to do something for fibers, I want to do something for automotive, then of course there are some guidelines, some regulations, some certification processes that are applying to specific value chains in packaging, in textile, automotive. This is not exhaustive because otherwise I would have maybe it's better this way, huh? Oh, yeah. Yeah, so if I would spend the time to try to get all the regulations, then you would have maybe 20 slides and one after the other doesn't make sense, but just to give you some ideas. So each of these industries are regulated, and we have products that can go in many different applications, and therefore we are confronted regularly to all in front or against all this kind of requirements. Now, if we look at specifically the end user industries which are served by plastics, and then we take the stance of the colorant producer, what does it mean for us, all these trends? If you take packaging and consumer goods, you will see that, yeah, that's good, I've got the screen here, better, okay. Yeah, so there is a target to get more and more reuse of plastics. We heard about this before. Recycling. I think European Commission said we should have 60% of plastics by 2030 which are either reused or recycled. So that's a big jump ahead. Yeah? But at the same time, people, they hear about, I want to get rid of plastics, but I still want to have food safety. I don't want to compromise for my children about food and basically any disease I would get from chemicals. Yeah? And companies, brand owners, they still want to have color, because if everything is non-colored, what happens? It's very boring. And color sells, and that's why color is there. So typically, when you look at those trends, what does it mean for color? And what we can see out of that, we believe that there will be less color. Less color because less prime polymer to be colored, because by design, some companies will try to, ease the recycle or enable the recycling. But at the same time, this headwind for colors will give us a trend for more pure and safer products, safer colorants. There is already something happening in the market. We see that already in Europe. For instance, for sorting scrap and waste in packaging, when you use carbon black in packaging, you cannot sort the waste because it's absorbing any infrared and you cannot sort your waste. So now there are already projects where people are trying to replace carbon black by other type of colors to make a black color. And here we are already working on that as BASF Colors and Effects. On the other side, for the consumers, we see 3D printing emerging. Now it's not really highly productive technique, but it will be also something that could maybe compensate for the lack of color in the primary packaging sectors. And again, when you look at the safety aspect, whatever we do, people will never compromise for consumer safety. Remember that packaging has allowed this industry to be extremely safe. The shelf life has been increased. Why? Because plastics are there, and you cannot really come back, and this will not be a compromise. Now, maybe looking at specifically that area, because I will come back to automotive fibers and building and construction later on. Packaging and consumer goods has been the drivers in the last 10 to 20 years for purity of pigments, purity of polymer compounds, and we expect that to continue. And we've seen that in the last years, regulation has become more and more complex, more and more demanding, and this is not going to stop. And in those applications, we include food contact materials, toys, cosmetics. The main driver is food contact materials, and why is that really driving the industry? Is simply because if you take the main regulations around the world, take US FDA, take European Framework Directive, take China Standard GB, all say the same. They say for food contact materials or packaging, any substance that is in it, which may migrate in the food, of course, they are not supposed to migrate, but which may migrate into the food, must not endanger human health. That's typically what we are doing. Making sure that at the end, whatever is in the packaging would not migrate, or if it migrates, would not endanger human health. Additionally, those regulations are saying, yeah, if something migrates, even though would not endangering human health, it should not bring any unacceptable change in the composition of the food. Clear. Or it should not bring or deteriorate the organoleptic properties of the food, means the taste or the color. Yeah. Now let me come back to the other industries we serve. Automotive industry, for instance. Here we talk about e-mobility, e-efficiency, because electrification of cars being more and more autonomous in the future, lightweight. I think Milton, they mentioned that this morning. People being in the car car being autonomous, people will have more time to stay in the car and entertain themselves. And we see now more and more prototypes coming where the car is not black inside anymore. There are lots of nice things put inside. So more comfort, more design put in the interior of the car. And all this will be about saving electricity, saving energy to drive farther, but meaning that the effect of heat buildup within the car because of black plastics would have to be managed. And also all these sensors that people are putting around the car to manage to have autonomous driving of the car, that's also about infrared light management. So typically here we see for pigments or for functional pigments, we see here an interesting future. We see more plastics coming with more colors, especially in the interior. On the other side, for comfort purposes and quality image, low VOC, that means no volatiles anymore. You remember maybe many years ago there was lots of fogging in the car. You know, the glass was full of special chemicals that were just adhering to the surface. Odor perception in the car is also becoming important. Again, infrared light management means you don't want to have heat build-up in the car because then you will take a lot of energy to have air conditioning of your car, and that means the energy consumed for cooling down the interior will not be used for going farther with your drive. Another trend we see, with JADSL, I guess you heard about this, IMDS, there is now a need for banning some hazardous chemicals, and these are listed or even sometimes banned. Maybe just to give you an example, that was I think in China, where in 2017, those chemicals or VOCs were basically limited, and then for most of them, then the limit has been reduced. That means here the trend is clearly towards purer and purer plastics, meaning also sometimes pigments can contribute by bringing some of these chemicals, and that means then we need to improve the products in a way that we are meeting those new requirements. Maybe on the fiber and textile now, we talk more here about sustainable fibers. You heard about, more than myself, I guess, about the Water Pollution Act, where in fact, any process that is consuming too much water, creating problems for water treatment, basically has to be banned or at least changed. And here there is a trend towards more mass dyeing for fibers. The fiber materials are competing with each other. Polypropylene, polyester, polyamide, we see a clear trend towards polyester gaining the race. Also because of recycling. Polyester bottles, when people use them, they can usually end up into fibers, rugs or even apparel. And we have more and more need for certification of textiles for consumers. I think I mentioned before the Ecotex, I will come back to that. So typically here we see that, there will be new coloring techniques for fibers. Some people also now taking the fibers and print those fibers. There is also liquid colors now applied instead of mass coloration via granules, then it's done via liquid colors. So typically here there is a trend for new and different coloring techniques. Polyester will gain the race, and again here pure and safer colorants, again by banning some specific chemicals. One example is this Ecotex Standard 100. It's an independent testing and certification systems. It looks at overall textile processing steps. There are clearly formulated test methods, authorized testing institutes, regular product checks, on-site visits, sometimes not pre-warning. So basically people can come in and check where and how you do your products. Typically here, the idea is to ban or limit via threshold values the use of hundreds of substances. And in fact, those substances are coming from already regulated substances. So they are not reinventing the wheel. They are basing their list on already established regulations. REACH in Europe has done a great job in understanding which chemicals could be a problem and which chemicals are safe. So the work has been almost terminated now. ECHA, which is European Chemical Agency for substance of very high concern, US also specific listings or approaches. We have also, on top of that, even though not legally regulated, there are some substances that Oecotex is putting as to be regulated. That means to be limited in terms of content. Just to give you a list, there is this polycyclic aromatic hydrocarbons, chlorobenzene, chlorotoluene, phenol, styrene compounds, genetically modified organisms, pesticides, flame retardant additives for some of them, even some UV absorbers, benzotriazoles. So there are lots of different chemicals being under watch. And then to be certified, you have to make sure that you comply to those requirements. So we need, as a pigment industry, to continue adapting ourselves, because those requirements, which is a good step, push us to get more and more pure, push us to get better and better in performance. Maybe the last one, green buildings. Here, yeah, durability becomes the key, and it's still the key driver. Energy efficiency, some people talk about energy positive buildings. Yeah. And functionality, and again here, heat buildup, air conditioning is also important in terms of absorption on infrared due to carbon black. You can move it to other colors, and then you manage to have less heat buildup in your house. What does it mean for us, all these trends? We believe that PVC will remain the polymer for use in construction industries because, in fact, it's highly durable. That means when you put a plastic for 30 years into an environment, into your house, then it's not going to end up in the ocean. It's going to be there. And that's typically where it should be used. Low heat buildup colors, again, for functionality, and ban more and more hazardous colors. Now, that was the different industries and specific areas of regulations. Now, we have also many other approaches. We heard about the bioplastics, biodegradable plastics, the European norm, waste management for recycling in Europe, EPA approach. Then more specific, cradle to cradle or life cycle assessment done for the industry. But in fact, here we cannot really put those into specific industries because they are in fact across industries. And here we talk mainly about this topic that was discussed this morning: reuse, reduce, recycle. Yeah, and we have these famous, 6 levels of what to do with plastics. Now, if I just draw a value chain, which is very basic, the fossil feedstocks, plastics material production like polyethylene, polypropylene, plastics articles like a film, like injection molded product. Then I would move into the product use. I use my film, and then what do I do with my waste? Landfill, people say no. Incinerate, reduce as much as possible, it should not be. Energy recovery, which is a little bit better, limit as much as possible. So here we can expect to reduce the CO2 emissions. Recycling, reuse, prevent should be the way forward. Now we try to understand, for coloration of plastics again, what are the different scenarios for recycling. If I take now the first example, reuse, of course we have less plastic for us to color. That means there will be less demand. On the other side, when you use several times the same product, you need to have better performance, better durability. So in fact, we would maybe have less product use, but maybe better quality products. If you take the second scenario about mechanical recycling, then you have less colors by design, because to allow several steps of recycling, you may say, okay, I prefer to have less color. I got the case, people in the fiber industry in the US, they want to have Coke telling people not to have their bottles colored, because when they take the bottle of Coca-Cola to make fibers out of it, they have problems to color it. So typically there is a push within the value chain to try to avoid some parts of the industry coloring their plastics. Now, there will be also less plastics to color because you recycle the same plastics, maybe more scrap to color again, but not sure. But here what we can say is that when you need to do mechanical recycling, you don't want to bring via your old plastics more impurities, more scrap. And that means here the colors you're going to use will be more pure and more stable during processing. We should avoid colors that are migrating, so better migration resistance. And here, again, the carbon black would be hindering the waste. That means if you want to recycle and sort your scrap, you need to take out carbon black. At least that's what we see in various countries, especially in Europe. Another scenario would be new cycling, means you take the polymer which is here in the article and then you dissolve it. There are some projects nowadays in industry trying to prove that concept. And here again, what does it mean for us? You don't want to let impurities in your dissolved plastics, and you want to be able to extract the color. So far, we don't know how to do it. So that would pose a problem for that specific route moving forward. And the last possibility is, I think that was mentioned by Rowan this morning, is the chemcycling. I'll come back to that later. Here, basically, you take your plastics waste and you make new bricks for making new products out of it. So instead of digging your oil from the ground to make new plastics, you just take the old plastics and you break them down into individual bricks, and then you make new plastics, but you can also make new additives, you can make new pigments out of it. So that route would be via this kind of specific oil making from there. For us, no change, again, state of the art. And again, that means you can make new products which are, again, food contact safe for the consumer, etc. And if you have another route, which is depolymerization, here, of course, again, you have the same problem of, I want to extract my colorants from there. I want to avoid using carbon black because I cannot sort my waste. Okay, so that's typically, try to summarize, but it's a complex topic. Of course, you've seen that already today. Now, maybe something that we mentioned, and I think there was a communication by BASF just in December, where in fact we have managed to make out of that specific chemcycling project. Imagine you're the consumer and you pass by our site and you let your waste there, and then what we do, we make out of that waste a new feedstock for making any kind of new products, either pigments, additives, polymers, foam, etc. And then it can go to the consumer market, but then without any residues, without any impurities, because you really start from the bottom of the chemicals. That means you're sure you master your full chain in terms of safety. And then once used again, then your waste, instead of being put in the land or put incinerated, then you bring it back to the site and then you can start again. That means virtually you stop using fossil feedstock, but you use the already existing waste to make new virgin products. So I think this will take time before it goes out, but typically here the concept has been validated recently, and I guess BASF will continue here. This is for the major, market. I think we heard this morning from Rowan there was 1 or 2 million biodegradable plastics available. This is a technology that could mitigate millions of tons. So we talk about different size here, because remember we have 350 million tons of plastics made every year around the world. Okay, maybe just to summarize on the requirements for colors for plastics, what will come less and less, that means less virgin plastics to color, because we believe the dynamic that is started last year and continues. People by design, they will try to put a little bit less plastics. Again, this carbon black topic will come more and more, so here new solutions also to be developed. On the other side, here we see that we will get safer and purer products, colorants. We'll have also, again, in the purity side, lower VOC containing products and no odor containing products, or no odor bringing products. If you think about recycling colored plastics, that means the plastics, when recycled 1 time, 2 times, 3 times, they will leave different processing histories. And then at that stage, you need to select the colorants that will be the most stable. Otherwise, every processing step, you will start to create some impurities. Again, scrap plastic to recolor, because if you use less color with the prime virgin polymer, you will likely get more scrap to color again. There was a nice green flower pot in the hall. We may have cases like that, but still to be proven. Now let me come to the second part of the presentation, which is basically about examples we've been living to tell you how we can manage to address the challenges of the industry, and then see from there what solutions we can bring to get the products purer, to get the products safer, or to mitigate processing issues. The first case is about purity and safety. Heliogen green pigment, I guess you heard about this color index. Pigment green 7 is the workhorse of the industry around the world. Everybody, when they make green colors, they use that type of pigment. It's very widely used, including for food contact material. It has been used for 50, 60 years in all countries for that purpose. However, this pigment chemistry, and here I don't talk about BASF specifically, but the chemistry itself, it has inherently in its composition potential presence of what we call a NIAS, not intentionally added substance, somehow impurity, which is called HCB. And in that case, this HCB is classified as CMR, carcinogenic, mutagenic, reprotoxic. I don't want to frighten you here because, pigments are used in very small amounts in plastics, and not every pigment has got this case, but here I'm going to highlight the cases where there is a need to act. By chance, for this NIAS, we have well-documented toxicology, so we know what is the daily intake which is possible with this product by the toxicologist, and we know also what kind of exposure limits can be tolerated for those products. So what has been our initiative here to act on that? We are, historically speaking, the market leader for this chemistry. This product is the market standard, basically. And what we have done is typically we have taken that product for that study, and we've been doing a risk assessment for the use of this product into food contact materials. Okay? And then out of that risk assessment, so we run real migration studies into food simulants, etc. And then we have seen that basically, even though the product has been used for 60 years, for some specific type of foods, we don't talk about water, we don't talk about standard food, but more fatty dairy foods, there could be here a risk for migration. So here, what we have done is to basically restrict the use of our product for those kind of applications. However, we said the industry needs that product. So what can we do to purify our product, to purify our process, to make sure at least that we can help the industry to use that product for those applications? And that's what we have done here. How do we purify the product? So what we have done first is to develop test methods to really understand the content of this NIAS into the pigment, because so far nobody was able really to assess exactly the content of this NIAS into the pigment. And then secondly, we have been optimizing the process. And here you can see that, this chromatograph, I guess, you can see that here we have initially the process with the peak representing that impurity. And by optimizing the process and working on the processing conditions, then we've been able to reduce that impurity to that level. What does it mean at the end? It means that just that even though there is initially some NIAS inside, you can reduce it in a way that you can recover at least partly your food compliance. Additionally, what we have done is that we have been monitoring every lot made for 5 years, checking lot after lot how much we could get. And once we have got a stable level of purity that we could really confirm and basically monitor, then we've been able to restore food compliance on the product. Now, the second step has been for us to check our purity compared to what is available in the market. And that's typically the surprise we had somehow that, we took around 12 different products, flying in the market, and we could see that the levels, for us, we already have a limitation for use with that level of NIAS. Okay, so we are not fully covering all the application for this dairy food type of products. There is a kind of limiting concentration. You can see that the best following player in the industry is already higher than us, maybe 3 times higher or 4 times. And then average of the industry amongst the different batches is already showing a pretty high level. And the worst flying product is really, in fact, should not fly. So just to summarize, we've been modifying our food contact certificates. We've been basically providing support to understand the migration of these NIAS, and we've been modifying and improving our process to make sure that the purity level was the best in the market and offering better security for our customers when using the product. Note that using a pigment preparation that is based on that product, called microline, then you can even further increase the possible use of that pigment into the application. Because we select the pigment that goes in that preparation, and there is a partly cleaning effect during the process that is taking out also further impurity outside. Okay, maybe second example is a red pigment going into a cap application. Here the challenge was basically that, DPP pigments is the standard red in the market. Everybody is using DPP pigments, pigment red 254 in that case. We invented that in the late 80s. It has been used for years without any issues in food contact applications. We provide food contact certificates which are regularly updated, so the product is very safe for use for many years. However, some people in the industry have been using that product for water caps. And in that case, the requirements for water caps are also including off-flavor potential issues. And here, we have been basically requested by the industry to really check whether the requirements that was set for more than 20 years that was successful would maybe need to be refined to address that potential topic. So what have we done? First, understanding if there is any potential issue of flavor, what does it mean? And where is it coming from? It could be coming from these so-called NIAS, which are basically all these possibilities, impurities coming from raw materials, solvent, side product reaction during the pigment synthesis, breakdown of products during the processing, cross-contamination because you may have multi-purpose plants, logistics, contamination, etc. So typically, you try to understand if something could give enough flavor to the product. What we have done here is looking at this forest of peak. Again, any chemical would have that. Don't worry, because all the big peaks are known because that's the product itself, or these are side products which are well known and have been risk assessed. So here there is no problem for risk or consumer safety. But when you talk about off flavor, it's so effective, a compound that can bring a flavor, that you talk about small peaks here, for instance, that could bring that kind of problem. There was a case in the wine industry years ago where, in fact, there was a chemical compound in a wine that was giving off taste to the wine at the level of 0.03 ppt, parts per trillion. So typically, it would be like, 1 ppt would be like, here you try to find which grain of sand in that hill is responsible for the problem. So again, I don't want to give you the impression that we have lots of impurities in the products. We talk about very, very small amounts into products used as very small amounts in plastics. Yeah. So out of that study, we have basically put a group of experts together. We have developed, again, analytical methods. We have synthesized on purpose 20 different compounds with R&D colleagues out of 50 possible structures to really understand whether those ones would really be the ones that could bring the problem. And we have given those samples and discussed and partnered with Fraunhofer Institute in Germany that those experts are able to understand each chemical and really sniff each of these chemicals to see what they can bring as a taste. And finally, we could confirm that DPP chemistry can bring a flavor somehow in some specific cases. The side products are coming from unspecified impurities from either raw materials or also manufacturing process. And we have been able to basically define the limit of these NIAS to be present in order that you manage to avoid this off flavor. So basically, we have finally refined the quality control and specification for the products, for both the incoming raw material and also for the finished goods coming out of the plant. And then, of course, supported by test method. Just to give you an idea, in the last 25 years, we had this specification for the specific purity level of the raw materials. Here we talk about 99.9 something percent. So it's a very, very small amount compared to what you get as a raw material. And in fact, what we have seen is that out of these specific potential impurities in the raw materials, we have identified, for instance, here the yellow and the green to be the ones which would be triggering those soft flavors. And then out of that now, we move the level here from there to there for these specific two impurities. So just to tell that every time there is a need for the industry to move into a more pure product to better control what could happen, we are taking the steps, working together with the industry to basically now take new measures and put new specification in place. And out of that, we have been launching one product that is called Red K 3840 UP. UP means upgraded product or utmost purity. And this one has built-in specifications to make sure that at least we control the presence, at least in that case absence, of these off-flavor active substances. And we have also the low warping version that has been upgraded accordingly. Maybe I try to go faster. Oracet yellow, that's another topic where we talk about purity for Ecotex type of standards, residual solvents, low VOC. This product has been used for many years. It's pigment yellow 147. It's an industry standard for a lot of different polyester packaging, but also fibers for apparel, carpeting, automotive, etc. And here we need to, of course, comply to food contact regulation, but also follow the certification. Because those products are made into solvents because it allows them to have high performance, but of course, you need to make sure that the solvents and the residual compounds in it are washed away and taken out. So what we have been doing is that checking whether we comply to those, at the same time then do a benchmarking again, because some people are just telling us, okay, I've got another pigment yellow 147 I can buy, I don't care, it's okay. So we say, okay, are we comparing apples with apples? And that's what we have done. And if you look at what you are making ourselves, we took 3 different lots, and we took a market from China and a product from India and a product from China. I don't remember which one was China, which one was India. Sorry for that. Solvent residue seems to be okay. Now, when you start talking about residual elements, here we talk about heliogen. Here we talk about metal elements. You start to see the curves are differentiating. And in plastics, if you start to put either iron or copper or whatever, you may have a lot of surprises later on during the lifetime of your plastics. It could initiate degradation, etc. And then if you move into residual raw materials, you see here the gap is widening. And if you take here now side products, which is not exactly the product you wanted to make, but something a little bit different, you start to see that there is a big deviation coming in. And of course, this is then reflected afterwards into the final properties, processing stability in fibers. Compared to our benchmark, those products will be inferior. Dispersion behavior in fibers, again, will be inferior. Food contact regulation will be slightly better because in that case, the regulation is not differentiating enough. And if you have a purer product, you can expect better coloristics as well. And that's what happens. Last example I have, Paliogen Red. Here, that's a topic where we use that for food contact packaging. And what happens is that the pigment is fully assessed as a powder pigment, and going into plastics, it's okay. It is food contact, high purity level, etc. What we find out is that into a specific resin, polyamide resin, under harsh processing conditions, then the end article producer was facing the problem that some aromatic amines were created at a very, very small level, very tiny level, but those are regulated very heavily. And in fact, what they could see is that there was a slight, incompliance because they were going beyond the limits. And why? Because this amine brought from the pigment was very small, but if you process one time, you start to create a little bit of these amines. Now, since it was a film and you need to have a very good dispersion for the pigment, then the master batcher was processing a second time, sometimes even a third time, to really achieve a very good dispersion because there are thin films. And in fact, then every step you process, then you create a little bit more, and then at the end, when you make the final film, you started to have these issues. So how do we manage to do that? First, we work together with the industries, with the people involved. Then finally, we could confirm there was some NIAS generated during polyamide extrusion. Yeah? Again, not big amounts, but sufficient to start, causing some uncompliance from time to time. These are the NIAS that have been identified as being, originating from that processing. What have we done? We basically update our food contact certificate because for every product we provide to our customers, we have this food contact certificate with it. And then we said, okay, please process at low temperature because that's linked to the higher processing temperatures. And please monitor the presence of those NIAS in your final film application, because the responsibility of the final compliance lies with the article producer, doesn't lie with us or doesn't lie with the polymer producer. And there is another step that we could do, that using microlene route again, because microlene allows to disperse the pigment very efficiently at room temperature. But what you do is that you have the same starting material, but you only process once in your master batch. You don't need to process twice because you already disperse your pigment. And that means systematically you are clearly below the regulatory limits. And that's a way we can achieve, or we can go around the problem by providing a product that has better performance from the start. Okay, maybe a conclusion and then I'm done. Basically, maybe before I go to the conclusion, more and more we are going to see regulatory bodies policing the compliance. You may have heard about RASF in Europe, which is this European community with Switzerland and all the Norway, etc., where people are looking at every food contact product or food coming into Europe and check its compliance. We just got their report. Last year, 357 non-compliance notifications were made. Most of them were for the food itself. However, out of those, 18 were linked to the packaging. Out of those, 14 were coming from China. It means there is also 4 that were coming from other parts of the world, don't take me wrong. Out of those, 8 are plastics products. So you may say it's not too much, 8 for plastics out of 357, but still too much, okay? And then we can say that out of these 8 cases for plastics, you can see that in fact color is maybe 1 case. And maybe people took the wrong pigment that was not food contact compliant. But you can see in some cases presence of heavy metals. In some cases, presence of regulated chemicals. And in some cases, primary aromatic amines. That could mean here interaction in the polymer compound during processing, whatever. So we see that more and more happening, that bodies, and now in Germany they have put a team in place where the authorities would check. They will randomly go in the shops and then start to check the packaging and the food. And then if something happens, there will be dramatic consequences. Another example I had was for textile and footwear. I think that was in China last year. 3 recall of products out of 21 cases. 1 lead, likely lead compounds, pigments potentially. Heavy metal and phthalate might be linked to PVC, and again PVC coloration, and formaldehyde, something else. So here we see more and more this kind of, not product recall, less and less, but more and more attention and policing of those. Let me finish just maybe by give you a summary of what we've done. So we somehow share with you today what we see as an impact of these trends onto the coloration of plastics. Yeah, we believe there will be still need for safer and purer products in the future. And if there is a case, if there is an issue where some final articles would have a limitation for use because of the coloration or because of interactions, we are committed to support. And the cases I've been giving you here have been 2 of them proactive from us and 2 others coming from interaction along the chain. And we are very much upstream. So if you don't tell us what you need from us, it will be difficult to define that by ourselves. So we only progress by working together as an industry. Yeah. So thanks for your attention. I hope I was clear enough and maybe too long, but okay. Thank you.